Coming up a week from today. Today, Tuesday?
Yeah.
Okay. All right. So you're going to need to know the polynomial long division, the synthetic division, and also the...
Your battery's low.
Are you going to do a review on Monday?
Yeah. But we already had a test with some more stuff with polynomials and zeros, and what we're doing today, which is
Nothing.
rational expressions.
Are you going over homework?
Can I go over at the end?
Yeah, I was just wondering.
Yeah. Rational expressions. I'm kind of on a roll.
Alright, that's fine.
Okay. Today's the 27th, yes. Today is the 27th of 2009. Rational expressions. Okay, a rational expression is a function which consists of a polynomial function divided by another polynomial function. That's why this comes right after long division. We'll tie those two together. Probably not today. Okay, rational expressions are a fraction where g of x and h of x are polynomials. Nope, not yet. At the end I will. Okay. The big thing we're going to be doing this unit is graphing these puppies. Okay? So you got to learn a bit about how they behave. Now having a polynomial on the bottom can make this really problematic. G of x and h of x are polynomials. Go right to an example. That won't work. We're going to talk a little bit about zero today. I'm going to go right to an example that combines a couple of ideas. Okay. Does this have a polynomial on the top and a polynomial on the bottom?
Yeah.
No.
No, it's got a polynomial on the bottom, right?
Not on the top.
They're both polynomials, actually. A line is a polynomial. A line is a polynomial because if you remember the rule of polynomials, it just said no irrational coefficients and all of the exponents had to be positive whole numbers. What's the understood exponent here?
1.
1. So this is a polynomial on top of a polynomial there. Graphing these things is interesting. You might know this is a line, you might know this is a this is a parabola. Won't really help you graphing either.
Don't you have to put the x to the second, like, split to the
Ah, do you think you see a way to do that? What does Michelle? Michelle just noticed something. What'd you notice?
You can do x plus 5 times x minus 5.
X plus 5 times x minus 5.
I was going to say just make it x minus 5 at the end.
Well, here's an interesting thing that happens, okay? X plus 5 over x plus 5 times x minus 5 is, can I cross, okay, these are two factors, two things being multiplied on the top, one of them saying something on the bottom.
You can do that.
I can cross them out, and this just equals x minus 5, and how would I graph x minus 5? What would that look like, Sam?
That would look like it would go through, it'd be a line, it'd be
With a slope of,
slope of 1,
correct?
and it would go through the y-intercept at 5.
Go through y-intercept at negative 5.
Oh, negative.
Yeah. Okay, here's the problem with that. Yes.
When you're trying to find, like, you guys, I mean, when you got x minus 5,
Yeah.
can't you, like, just look at it and x squared, you
No.
subtract the exponent to get x, and then negative 25 divided by 5, negative 5, so it's
Nope. That was coincidence. I should have picked a different example to start. That actually won't work. You can't do the x by the x and the 25 by the 5.
Oh, because it's adding.
Yeah, but by sheer coincidence, this one worked as if you could.
Yeah.
My bad for picking this example, actually. Okay, here's the problem with that. This polynomial looks like it reduces to x minus 5, except if you graph this, if you graph it like this, it doesn't look exactly the same. There's a problem here. Okay? If I put most points into this and into this, I'll get the same value, except for one. What happens here when x is equal to -5?
You tell me.
Well, put -5 in for x here, and what do you get?
Oh, you get -10.
Nope. Yeah, you're correct. You get -10. Okay? Put -5 into here, and what do you get?
You get
0.
You get -5 squared minus 25.
It's undefined, right?
Close. And you get,
Oh, wait.
Is it 1?
Yeah, I guess so.
I get a 0 on the top,
0 over 0.
0 over 0. What's 0 over 0 equal?
0.
Nope.
1.
Nope.
Nothing.
New word. Indeterminate form.
I was going to say that.
There are three things that are going to happen with,
0 goes into 0.
actually it doesn't. It's even weirder than that.
No.
You're going to get an indeterminate form. Okay? Amy, follow me to this board for a sec. Okay? Three types of fractions with 0. Okay?
You get over 0, 0 over something, and
0 over 0. Yep, those are three possibilities. A fraction bar means division. And division is reversed of what? Multiplication. Everyone else join in. I don't want to just, as much as I enjoy just chatting with Sam, I'd like some more people in the conversation.
That was Michelle.
Hi, how
Okay.
was your weekend?
Thank you, Dean. Okay, three types of fractions with 0. If I have 0 over 5 equals blank, don't answer it yet. This is a restatement of the idea of blank times 5 equals 0. Every division problem can be rewritten as multiplication. What times 5 does equal 0?
0.
0. So 0 divided by 5 equals 0. There is no problem there. Life is fine. If I have 5 over 0 equals blank, this is a restatement of the multiplication problem, blank times 5, blank times 0 equals 5. What times 0 equals 5?
No, well, we don't know.
It's undefined.
Yeah, it's the short answer is not
Nothing.
a darn thing. And since it's nothing, we can't define anything that we can multiply times 0 to equal 5. We say that 5 over 0 is undefined. We can't define anything that'll work that way. Here's the other situation. 0 over 0 equals blank is a restatement of blank times 0 equals 0. What makes that statement true? Anything.
Indeterminate. It's unable to be.
Yeah, but it's indeterminate. We can't determine any one thing that will have the property of being anything. If you like having it phrased poetically instead of mathematically. Yeah, anything could make this true, but we can't graph any old thing.
I don't understand why 0 over 0 just doesn't equal 0.
It can equal 0. But the problem is, I could put 0 into this statement to make it true. Okay? When you're putting a fraction together, okay, that's the thing. You guys get so used to seeing fractions, you forget where they came from. A fraction is rearranged multiplication.
Yeah.
Okay? A fraction is always a question, what can I put into the inverted multiplication problem to make it true? Okay? I could put 0 in to make this true. But the problem is, what else could I put in to make it true?
1.
What else?
I mean, any number.
Pi, 57,
But,
you know,
so
Six.
when you're doing 0
That looks like 5T.
over 0,
does.
you do, are you doing 0 times 0?
No, when you're doing 0...
times 1 over 0.
Those are all just different ways to write this idea. This multiplication is the core idea.